Okay, today I'm going to talk about chemical kinetics, a very interesting subject matter, and I hope you find it equally enticing as you have found all the other videos that I put up so far. First of all, we like to talk about factors that affect reaction rates. Okay. I think it's very important to know what are the factors that affect reaction rates, simply because if you want to be able to control a reaction, or we want to know the end products of a reaction, we have to be very familiar with the factors in the first place. Now, before we start anything, let's have a look at the concept of chemical kinetics. Chemical kinetics is nothing but a study of reaction rates or the changes in concentrations of reactants and products with time. By studying kinetics, insights are gained into how you can control a reaction, and the conditions that you need to achieve a desired outcome. Now, there are four factors here which basically control chemical kinetics of a reaction. One is the reactant concentration, 2, the temperature, 3, physical states and surface areas of reactants, and 4, solvent and catalyst properties. Let's take a look at each of these one by one. Now, concentration effects. Two substances cannot react with each other unless their constituent particles come into contact. As strange as it might seem, this is a very important rule. If there is no contact, the reaction rate will be 0. Now, in nature, we have something called occlusion. This occlusion is basically where the material of interest is encompassed by an external material, another material, completely cutting it off from any possible reaction. This could be, for example, a capsule containing some powder inside. The powder is now cut off from the environment simply because of the coating of the capsule. And you have other examples which you can think of easily. The more reactant particles that collide per unit time, the more often a reaction occurs between them. Okay? The rate of reaction usually increases as the concentration of the reactant increases. This is, well, quite understandable, because if you have just one particle trying to collide with another particle, the chances of your reaction taking place is quite low if it is happening in a huge environment. But you have 1 million particles colliding with another million particles in the same volume. Needless to say, then, the chances of the reaction taking place is very high, and the rate of the reaction accordingly increases. Increasing the temperature of a system increases the average kinetic energy of its constituent particles. That's quite understandable. As the average kinetic energy increases, the particles move faster, they collide more frequently per unit time, and therefore possess greater energy when they collide. This results in increase in the rate of the reaction. Now, rate of all reactions increase with increasing temperature and decreases with decreasing temperature. There's no explanation needed for this. Let's talk about phase and surface area effects. If reactants are uniformly dispersed in a single homogeneous solution, the number of collisions per unit time depends on the concentration and the temperature of the medium. If the reaction is heterogeneous, the reactants are in two different phases. Therefore, collisions between the reactants can only occur at interfaces between phases. Right? Not the entire two media, but at the interfaces only. Therefore, the number of collisions between reactants per unit time is reduced as the reaction rate. Now, the rate of a heterogeneous reaction depends on the surface area of the more condensed phase. This is what you need to remember. Okay. Looking at solvent effects, the nature of the solvent can affect the reaction rates of solutes. Solvent viscosity is also important determining reaction rates. In highly viscous solvents, for example, dissolved particles diffuse much more slowly than in less viscous solvents, and they also tend to collide less frequently per unit time. Rates of most reactions decrease rapidly with increasing solvent viscosity. And then we have something on catalysts. You know what a catalyst is? If not, I'll be talking about it soon. A catalyst is a substance that participates in a chemical reaction. Okay, let's highlight participates here in a chemical reaction and increases the rate of the reaction without undergoing a net chemical change itself. That's the most important part of the definition. Catalysts are highly selective, and often determine the product of a reaction by accelerating only one of several possible reactions that could occur. If you remember, in my earlier videos on thermodynamics, I talked about A plus B equals to E plus F equals to G plus H then becomes equals to C plus D. So you have so many intermediate steps. A catalyst could in fact work on any one of those intermediate steps. Alright, so I hope you enjoyed the video thus far and keep looking out for more videos on chemical kinetics. Happy studying!